Let me continue the class. Now the previous class what I said, what is force, what are the different views of the scientist, and we have seen inertia, that is the position of the object, then how the force act upon that. Based on force, it can be divided into inertia of rest, inertia of motion and inertia of direction. Now we have to say what are the laws of motion. I said already Isaac Newton is a famous scientist who is well known for gravitational force, and he has proposed the laws of force. Totally he has proposed 3 laws, that is known as Newton's law. Newton first law, second law and third law. Now we have to see Newton's first law. Newton's first law and inertia both are same only. So, see, take textbook, page number 3, because we should not disturb the words. The words what all given in the textbook you have to give as it is. This is the law. If you are writing the law, they have to give easily 2 marks. So, what is Newton's first law? Take pencils in your hand and mark down the important things. The law states that every body means what? Object. Every body continues to be in its state of rest or the state of motion. State of rest means what? That is in the resting position. Motion from the resting position, it may be moved. Whatever the thing may be, either the object is in a resting condition or moving condition, it goes along a straight line unless it is acted upon by some external force. So what I said, an object, it continues to be in its state. State means what? Either it is rest or in uniform motion. It will be continued, it will be disturbed because of a external force from the outside. So every body continues to be in its state of rest, or the state of uniform motion along a straight line unless it is acted upon some external force. This is known as Newton's first law. So by this we got, otherwise it is known as inertia. Inertia, I said already, that is the inherent capacity of an object. So from this we came to give a definition for the force. So what are the effects of the force? Force, I said already, it is the push or pull given by the external, but from outside. So what are the effects of the force? Force produces the motion and it stops the motion and it changes the direction. So what are the things? It produces motion, it changes the direction, it produces the motion, stops the motion and changes the direction. These are the effects of the force. Because force has magnitude and direction, it is known as vector quantity. We would have studied in the lower classes scalar quantity and vector quantity. Force is vector quantity because it has a direction as well as force. Magnitude and direction, it has both the magnitude and direction. Magnitude means what? Mass, that is the weight. So it has both magnitude and direction, it is known as vector quantity. Scalar quantity, only magnitude is there is no direction. We would have studied in the lower classes, that 6th, 7th and all, we would have just recall it. So magnitude alone means that is scalar quantity. Magnitude and direction, this is known as vector. Force has both the mass as well as velocity direction, it is known as vector quantity. Further, these forces can be divided into parallel force and parallel force. Parallel forces and unparallel forces. So on saying the name itself we know parallel. You know what is parallel? We would have studied in maths class, parallel and perpendicular. Parallel means they travel in the same straight line. They do not intersect each other. So in the parallel, for example, two forces are there. One is A, other one is B. Both the forces acting on the same line, they never intersect. This is parallel forces. Unparallel forces, both A and B, they are from different direction. That is, one is left to right, means other one is right to left. So both the forces acted together, either it is parallel or unparallel, whatever it may be, there should be some collision. Collision means what? Joining, the dashing, they dash each other. Because of the dashing, collision, they produce the momentum that is known as linear momentum. So let us see the book again, what is types of parallel forces. Two or more forces of equal or unequal So they may be equal or unequal in magnitude. Magnitude means what I said, mass. Either it may be equal or unequal in the mass. They are in the same direction. They are parallel to each other. They are parallel forces. That is forces. That is how many forces we have taken? Two forces. One is A, other one is B. Both have same magnitude. They are travel in the same direction. This is parallel forces. Unparalleled forces. Forces are in the same A and B only. They have the same magnitude, but they followed in a different direction. This is unparalleled forces. So they collide each other, they collide, collision, everything is same only. They dash each other and produces. For example, we are multiplying two numbers, we get the product the same, like they collide each other. That is A and B collide each other and they produce the result. That result is known as resultant force. That because of the force it has happened. So result means what? After writing the exam, we are getting the result. The same, like because both the things are collide together, they produce the result. This is known as resultant of force. So until in the important points, what is parallel force, what is unlike parallel force, and what is resultant. Now see page number 4, we can see the example for that. See the diagram C. That is two people, two men, they are carrying a truck. One is forwarding right side, means other one also, one is in front, other one is at the back. Both are pushing the truck in the same direction. This is an example for like parallel forces. For example, first person is A, the last person is B. They keep their force in the truck, so it moves towards the same direction only. This is like parallel forces. And unlike parallel forces, you can see in the A, that is tug of war, that is a thread. So one side A group of children are there, three children, and the other side B group. So A group pulling towards them, pulling B group children towards them. The same like B group children pulling the A group girls towards them. அதாவது இவங்க வந்து ஏ வந்து அவங்க பக்கம் ஃபோர்ஸ் கொடுத்து இழுக்க பார்க்குறாங்க. the same like. So this is known as what? Tug of war. Here both the group of children A and B, they produce in different sides effect. This kind of thing is unlike parallel forces. The first one is like parallel forces, that both are putting their effort in the same direction. The next one, unlike parallel forces, here also two groups are acted on that. They exerted two forces, but they act in the different direction. This is unlike parallel forces. The forces may be balanced, that is right side should be equal to left side. That is balanced force. If it is not balanced, that is known as what? Unbalanced forces. So whatever it may be, rotating, without rotation nothing can work. For example, a car, we know everything, whatever the object may be, we have load, effort, fulcrum. What are the three things are important? One is load. Next one is what I said, fulcrum. Third one is effort. For example, an object is there, that object is load. That should be lifted. For that you have to give the effort. Okay, yeah. So in between the load, the particular point you are giving your force means it is easy to lift the object. That is known as fulcrum. Load, an object lies in the ground, it should be taken away from that. So you have to give a force. That force is known as what? Effort. You are giving the effort in the particular point. That particular point is known as fulcrum. So based on this only, we are finding the wheels. Wheel, you know what is wheel? The center, what is there? Fulcrum is there. That is round part, axis. So around the axis there is the rim. Adu sutti rim balla irukum. And the axis la neenga strength kodutha da the wheel can rotate. So axis, otherwise in Tamil we have to say achu. Okay, yeah, we are moving like that only. This is known as rotation. Rotation constitutes the couple. So everything produces a force. Everything is so by rotating we got the force, mean that is rotation of the force. They need to move in a particular direction. That is known as what? Moment of force. The same thing is repeated again. Moment of force is otherwise, that is moment of force, otherwise known as what? Torque. The spelling is TORQUE. This is moment of force. What is torque? It is moment of force. It is torque. By using this application, the torque, we can get many benefits. But vehicles are running because of the torque only. Mostly all the simple machines are fine by the torque. It is also, because it depends from the force, it is also a vector quantity. For torque also a vector quantity. It has magnitude and direction. This torque constitutes a couple. So what is couple? Let me rub the board. Children have got an idea. Laws of first, that is Newton's first law only we have seen. Based on the Newton's first law, we are finding what is parallel forces. Unlike parallel forces, they act in a particular direction, that is moment of force. They are rotating in a particular point, that is fulcrum, that is moment of rotation. And moment of force is otherwise known as torque. What is torque? We will see now. That is also a vector quantity. It has magnitude and direction. That is acting in a different particular point. That particular point is known as what? Axis. Force acted in a particular point. The particular point is known as axis. That is otherwise known as torque. Now we have to say what is couple. What's the meaning of couple? Pair. And knowing the name itself, we know two forces acted together in the same particular point, they constitute couple. Two forces acted in a particular point, they constitute the couple. Let me see in the book. Let us see. Two equal, underline the points. This is 2 mark question maybe. Two equal and unlike parallel forces applied simultaneously. Simultaneously means at the same time. At the two distinct points, they constitute a couple. Couple is very important for rotating body, because one is right side moving the body, means other side is left. Like that they can rotate. So moment of couple is known. This is by rotating the wheel, that is known as what? Moment of couple. Examples we can give for the couple, that is turning of tap. Tap, you know, the Quran solram paranga. Turning of tap, and binding or unbinding the screw. Screw we are making of tight or else removing the thing. Binding na நம்ம tight பண்றது, unbinding na remove பண்றது. And spinning of a top. Top means you know what it is. பம்பரம் சொல்றோம் பாருங்க அது. So what are the examples of couple? Spinning of top, turning of a tap, and binding or unbinding of a screw. So moment of a couple, in shortly we can say, that is moment of couple, force into S. S is the displacement. This is the force and displacement. In short we can say moment of couple is nothing. It is mass, moment, force acted on a particular object and it goes a certain distance. This is known as force into distance displacement. This is known as moment of couple. So by using this couple, we got many. What are the appliances? What are the uses of that? By using couple, what are the objects we are finding out? Gear, seesaw and steering wheel. Gear, you know, mostly boys know better than that, we are using in the vehicles. That gear, it helps to change the speed of rotation of a wheel. By using gear, we can make the speed high, or else we can rotate the wheel. This is gear. Gear is helpful. This is based on couple of rotation. The next one is seesaw. Seesaw, you know, both the persons are sitting on edge of the seesaw. Maybe one person may be heavier, other person may be lighter. Heavier person is easily can lift the lower person, because by giving effort, she comes near the fulcrum. So heavier person is easily he can take the other person, lower, weaker person, because he is very weak only. Heavier person giving less effort, though she has given less effort, she comes near to the fulcrum, that is the center point. So that makes the weaker person to lift the heavier person also. இவங்க வந்து கொஞ்சம் எஃபர்ட் போட்டால் கூட இவங்க அதுக்கு அந்த ஃபல்கம்க்கு நேர் அந்த பர்டிகுலர் பாயிண்ட்க்கு நெருக்கமாக போயிடுறதால, ஸோ வீக்காக இருக்கவங்க ஈஸிலி தே கேன் ரொட்டேட் த திங். ஸோ திஸ் இஸ் நோன் எஸ் வாட்? Seesaw. In the simple the couple, by using couple, they can easily, even lighter person, weaker person also can lift the heavier person. Next one is steering wheel. Steering wheel, we are changing the direction. If you are going by car or whatever it may be vehicles, you want to change the direction, you have to steer the wheel. So these are the applications, uses of couple. Couple, I say, two unlike parallel forces constitute a particular point or a distinct point, they constitute a couple. Moment of couple we see, that is force and displacement. By using the moment of couple, we can find out many applications, uses. What are the thing based on the moment of couple means gear, seesaw and else what? Steering of wheel. So clear are children what is, so based on Newton's first law we can find out force. Force la நம்ம couple வருதுன்னு பார்த்தோம். Turkish otherwise known as couple. It acts in a particular point. We can find out the moment of couple, that is moment is equal to force into displacement. F is for force, S for displacement. And based on this we can see the three application: gears, seesaw and steering wheel. So let me continue. Next one, principle of moments. We have different headings in this, so don't waste your time by taking the notes. Take the books in hand. As usual, the classes only this is, nothing else. Instead of seeing in a person, you can see through the mobiles. That's the difference between regular class and this. So whenever you are attending the class, you can take the pencil in your hand and underline the important points. Next one, we have to see principle of moments. Principle of moments. Moments means what? Moving. What's the principle based on that? When a number of like or unlike parallel forces act on a rigid body, rigid means strong. The forces act on a rigid body. Maybe they are parallel or unparallel, like, unlike. We can say like and unlike parallel forces also. They act on a rigid body and the body remains in the equilibrium. The sum of clockwise moments is equal to sum of anti-clockwise moment. So what I say, let me say again, when a number of parallel forces, number of like or unlike parallel forces act on a rigid body means strong body. The body is in the equilibrium in center. So then the algebraic sum of, that is the sum of clockwise moment is equal to sum of anti-clockwise moment. That additional words are just remove, algebraic and all don't want. Then the sum of clockwise moment is equal to anti-clockwise moment, that is enough. So here moment of classward direction we can see, that is first one F1 into D1. This is force 1, this is force, this is one force F1 and D1. This is the first force, the distance is D1, that is equal to F2, this is second force into D2. That is force acted on object and the object moved particular distance, that is known as D1 and D2. This is principle of moment. F1 into D1 is equal to F2 into D2. The principle of moments, what are the laws, what are the definitions, you have to learn for 2 mark answers. So is it clear? First Newton's first law, we have seen all those things, that is couple, torque and movement of couples we have seen. Next one is principle of moment, all the things based on laws of first Newton's first law. That is the objects remain in inertia, the objects remain in the state unless a force act on that. Whatever the state may be, either it is resting condition or moving condition, that can be changed by a other force which is acted from the external. Now we have to go for Newton's second law. Then we have to see what are the uses of Newton's second law. Second law, the force acting on a body is directly proportional to the rate of the change of linear momentum. The force acting on a body is directly proportional. That is force and then what I said, magnitude, both are in that same. இது இன்க்ரீஸ் ஆனால் அதுவும் இன்க்ரீஸ் ஆகும், இது டிக்ரீஸ் ஆனால் அது டிக்ரீஸ் ஆகும். அப்படி இருக்கிறது நம்ம என்ன சொல்கிறோம்? ப்ரொபோஷனல், டைரக்ட்லி ப்ரொபோஷனல். The rate of change of linear momentum of the body and change in the momentum, it takes in the direction of a same place. So it should be memorized. The same like, put a break in words, the force acting on your body is directly proportional. To what it is directly proportional? to the rate of change of linear momentum of the body and the change in the momentum. It takes place in the direction of the force. This is known as law of force. For example, whatever it may be, whatever the object may be, initial velocity is there, final velocity is there. Initial means beginning, final last. So before it starts moving, initial velocity of the object is u. Final velocity is v. We can say in other words, that is initial momentum of the velocity is p1 is equal to mu. M is the mass, u is what I said, velocity. The next one, final velocity is p1 is equal to mv. This is final, this is initial. P is the product. So mu by mv. So changing in the momentum, what are the changes in between? Maybe final velocity only more. So mv minus mu. In short, we can say P1. So whatever it may be, finally we came to the conclusion, force is equal to mass into acceleration, m into a. From where does we got the a? By subtracting mv minus, that is final velocity by initial velocity. Final velocity and the initial velocity subtract panna, we can get what? Acceleration. Acceleration is nothing else, it is the increase of the speed, velocity. Okay, yeah. Acceleration, velocity both are same only. The beginning stage means we can say velocity. If it is increased suddenly, that is known as final velocity. Force is equal to mass into acceleration. So gravitational force, everything come by this only. So Newton's second law, I said what is the law? Here we can say that is directly they are proportional. Initial velocity is, we can say initial velocity always we have to measure as u, final velocity v. Children, let us continue. Already you have seen what is Newton's first law of reaction, second law of motion, and we have to see Newton's third law of motion. It's the simplest one when compared with other two laws. That is nothing, for every action there is an equal and opposite reaction. Even for the usage also we have to say that is for every action there is an equal and opposite reaction. In the scientific term we have to see, that's given in page number 7. For every action there is an equal and opposite reaction. They always act on the two different body. So the forces acting on different body, not in the same direction. They are acting in different direction. We can set many examples for that. For example, birds. We have seen how the birds are flying. When the birds are flying on the earth, they push the air downwards. Okay, the birds flying on the earth, they push the air downwards with the wing. But air pushes them in front. So there is two action. That is, birds pushes the air downwards, that is action. But instead of that, the air pushing the bird to move up, that is known as what? Reaction. So every action there is an equal and opposite reaction. It is a known example. And two more examples are given in our textbook. The same, like a person who swims in water, we know well. While swimming water, we have to using our hands backward. We are forcing the water like this only. But the water pushes you front. Here also we can see an action as well as reaction. One more example, when you fire, when a gun, we are started the gun to shoot, trigger, when you are touching the trigger, the bullet has come out. No. So trigger we are giving the force at the back, the bullet has come in front. So like that, everything there is an equal and opposite reaction. One effort you are given me, the result will be in other direction. This is known as Newton's third law of motion. So what is Newton's third law of motion? For every action there is an equal and opposite reaction. They always act on two different directions, not in the same direction. So next we have to say, based on this law, we are finding out principle of, so which is very important in this lesson, means you have to see what is force. Then what are the three laws of Newton? First law, second law and third law. Any law they may ask, we should write 2 mark answers. All are 2 mark answers. Only Newton's third law of motion only, we may expect 5 mark also. Some examples are there, we have said already. Next one you have to say principle of conservation. What's the meaning of conservation? Conserve the water அப்படின்னு நம்ம சொல்லியிருக்கோம். Conservation means saving the energy. So principle of conservation of linear momentum. What's the meaning of linear? The same line. Momentum, the product. So principle means what? Based on that. So எதை பேஸ் பண்ணி இருக்குது அப்படின்னு சொல்கிறோம் பாருங்கள், that is known as what? Principle of conservation of linear momentum. Conservation, saving the energy, linear momentum in the same line. I said already, force act in the straight line only. So what is principle of momentum? So there is no changes unless a force act on that. This is the basic point. Whatever the object may be, either it is in the rest or motion, they will continue their action. Restல இருந்தாலும் சரி, மோஷனில் இருந்தாலும் சரி, மூவிங்கில் இருந்தாலும் சரி, அதனோடது என்ன ஆகும், உங்களுக்கு கண்டினியூஸாக இருக்கும். அன்லஸ் எ எக்ஸ்டர்னல் ஃபோர்ஸ் அப்ளைட் ஆன் தட். வெளிலேருந்து ஒரு ஃபோர்ஸ் ஆக்ட் பண்ணால் மட்டும்தான் தே வில் சேஞ்ச் த டைரக்ஷன். ஸோ here we have to see what is conservation. Conservation, saving, I said, linear, straight line, and momentum, the product of two forces together. For example, F1 one force, F2 one force. அந்த ரெண்டு ஃபோர்ஸுமே ஒரே லைனில் ஆக்ட் பண்ணும்போது, அதை மல்டிபிள் பண்ணும்போது அதனோட ப்ராடக்ட் தான் என்ன சொல்வீங்க, மொமெண்டம். So you see, you can consider how many forces are there. Two forces I say no. For example, first one is m1. This is one force. So அதனோட initial velocity u1. Next one is m2. This is other object. அதனோட initial velocity u2. Two objects you have taken. One is m1, other one is m2. m1 is object A. m2 is B. From the A, as per the thing, A acts on the B and both the thing is conserved. Conserved means what? Conserved, saving in the same line. So first one is, I said, A, object A. Other one is object B. Initial velocity of object A is u1. Final velocity of object m1 is, so A is u1, u2. Initial velocity, u2 is final velocity. This is v1. u1, v1. Final velocity is u2. Second object, this is B, this is A. Okay, yeah. This is the first object. Initial velocity is u1. Here, initial velocity is u2 because this is second object. And final velocity is v1. Here it is v2. The force is acting in between, that is here. F1, different direction. F1 is forward direction, means other one is in F2. So direction goes like this. F1 goes by this direction. F2 moves by this direction. So what is principle of conservation of movement? Though they are acting in different direction, they save the energy. M1 is A is the one object, B is other object. So force act on that. U1 is the initial velocity, U2 is the final velocity of A. The same like V1 is the initial velocity, V2 is the initial velocity. And after that we are finding the result, means M1 U1 V1 is equal to M2 U2 V2. This is known as linear momentum. So short we have to say, the absence of the external force, there is no force act on that. They are going on in the same line without any disturbances. No external forces acted on that. So in short we have to say, the absence of external force. Absence means what? There is no force. The thing is, the என்ன ஸ்டேட்டில் இருக்கும் அந்த ஸ்டேட் அப்படியே கண்டினியூ ஆகுது. ஸோ the algebraic sum of the momentum after collision, that is A collide with B after the collision is numerically equal to the sum of the momentum. This is known as principle of conservation. This is based on the law of Newton's third law. This is based on the function of Newton's third law. So we have seen the rockets and all, they sent to the space. So that is known as what? Rocket propulsion. What is the law based on that rocket propulsion means? You can say either Newton's third law of motion or principle of conservation of linear momentum. Both are same only. Newton's third law of motion and principle of conservation of linear momentum, both are similar. So they both express the same thing only. That is, both the forces acted in the same direction. They collide each other and the momentum will be conserved. This is known as principle of conservation of linear momentum. Linear straight line, I said already. Based on this principle, rocket is propelled in the space. Maybe fuel means what? Eripurul solram paranga, which makes the things to work. So that can be filled in the thing, and from here we are sending means it goes to the space with the same proportion only. So 1 mark answer maybe this is what is the principle based on rocket propulsion, means you have to say Newton's third law of motion, or you can write principle of conservation of linear momentum. Both are same answers only. This may be 1 mark because you know very well even 9th standard we got the questions in between within the lesson. So you have to underline the point. What is the principle worked on rocket propulsion, means you have to say either this or that. Clear? Next one, gravitation. It's familiar that Isaac Newton, who based the laws, these 3 laws, first law, second law, third law, he only proposed that the gravitational force also, whatever you throw up, it goes to certain height and then again falls down. This is known as what? Gravitational force. This also proposed by who? Sir Isaac Newton only. So based on that gravitational force, there is some force act on that. Suppose we feel somewhat heavy in the earth, but when we go to the moon, space, we feel somewhat weightless. This is because of gravitational force. Let us see what it is. Gravitational force, otherwise we can represent as G. So G, gravitational force. G for what? Gravity. Force applied on gravity is known as gravitational force. The value of gravitational force is 6.674 into 10 to the power of, this is measured by Newton meter. M, N capital and M is small letter, Newton meter. Nm means what? Newton meter. Gravitational force is 6.674 into the 10 to the power of minus 11 Newton meter. Clear? This gravitational force may be accelerated. Very beginning I said acceleration means nothing else, increasing. Velocity is the beginning of the speed, then acceleration is increasing of the speed. Velocity, acceleration, displacement, all are similar to, connect from the same word only. So gravitational thing is 6.62, 6.67. After decimal we cannot pronounce the word together like this. So we have to say 6.674 into 10 to the power of 11. So the main value of gravitational force is 9.8 meter second. Suppose a person 60 kilograms, 60 kgs in the earth means what's the weight of the man? So you have to find out on the space. You have to find out 60 into 9.8. So children, don't forget this. Just keep a note on that. We want to find out the person's weight. If he is, for example, 40, in the space how much he will be. So 9.8 into 40, you have to divide like this, multiple like this. 4 8s are 32, 39. 390. After decimal there is no value of 0, Newton meter. So what's the weight of the man in the space? 392 Newton meter. Like that we have to find out. So this is the basic thing. They may change the number. Don't depend on same number what is given in the textbook will come. It may be. The main thing, how we are calculating using the formula in maths, the same like you have to find out. Person's weight we want to find out means we have to multiply with 9.8 in space.